Welcome back everyone to this series of lectures where we start to focus on the hyperparameters for random forests. Since a random forest is an ensemble of many decision trees, many of the hyperparameters between both models are shared. Let's explore the important hyperparameters unique to a random forest. One of my favorite ways to do this is to actually directly compare the class calls in scikit-learn for a decision tree classifier versus a random forest classifier. For example, if we take a look at the criterion argument passed to both classes, you'll notice that we have to specify whether we're using Gini impurity or entropy for the information splitting criterion for both a decision tree classifier and a random forest classifier. In fact, if you take a very close look, you'll notice the vast majority of all these arguments passed to the classes are shared between a decision tree classifier and a random forest classifier. Really what that means is when you're using a random forest, you are setting up the same set of rules for all the decision trees in that random forest. For example, all the decision trees in the random forest will have the same max depth rule and minimum sample split rule or minimum Gini impurity decrease rule, etc. The main difference between the decision trees are the random subset of features they get to see when they're splitting at a node. And that brings us to the specific hyperparameters that we're going to be focusing on for the random forest. If we take a close look at the random forest classifier class call, you'll notice that there's really 4 key arguments that are different and unique to the random forest classifier versus the decision tree classifier. That is n_estimators, max features, bootstrap, and 𝑂𝒏_score. So that means that the random forest hyperparameters we need to learn about are number of estimators, number of features, bootstrap samples, and out-of-bag error. The first two are really just answering the questions, number of estimators, how many decision trees to use total in the forest. That is, should I have 10 decision trees in the forest, 100 decision trees, etc. How do we actually decide on the number of estimators to use? Then we have the number of features. How many features to include in each of those random subsets at each split? Then there's bootstrap samples. Should we allow for bootstrap sampling of each training subset of features? Which means we need to learn what bootstrap actually means in reference to the sampling. Then there's the out-of-bag error. Should we calculate 𝑂𝒏 or out-of-bag error during the training? Which also means we need to discuss how out-of-bag error relates to the bootstrapping of samples. Okay, let's go ahead and explore each of these hyperparameters in the next series of lectures, starting with understanding the number of estimators to use and the number of features to use at each subset split. I'll see you at the next lecture.